Hello and welcome back to my YouTube channel. I'm not going to dwell on this screen. If you've not been here before, do read through it all, videos, PDF, VirtualBox, read my selling points. If you've come here and you haven't got a link for the PDF notes, it's here. And today, well, we'll go via the Adhoc screen. These are the Adhoc video tutorials that I've already recorded. You'll find them in the Adhoc playlist at YouTube, and today we're doing the next part of Linux command line for beginners and Windows users, which is section 9, file permissions. So I'll go back here. These are the notes which you can download from iDrive. This is section 9, file permissions. Don't forget, like, comment and subscribe afterwards. And here I've got open the Mint 20 VirtualBox appliance. You can do this in CentOS and Ubuntu as well. It's all the same. I'm logged in as me. In fact, I don't want to be logged in as me. I think I want to be logged in as Train 1. Train 1, Train 2, Train A, Train X. The password for all of them is an X. And this has got sudo permissions, but it hasn't got anything set up. But there is a file in here called a file. And if you run a file with the dot command, you get colours on else and your prompt changed. So I'm going to do this from within here and look at file permissions there. So this section describes the different file permissions, how you change file permissions on a file or directory, describe how special file permissions operate. When I say file, I mean files and directories, because everything's a file in Linux, and set default permissions for a user. So we start with, I've already coloured some of this, never mind. We start with permissions on files and directories, do an ls-l, and you see the permissions to the left here, these 10 characters. Well, 9 of them are permissions. The first one is a hyphen, indicates a file, a D indicates a directory, and L indicates a link, as in this example. I don't have any links there. But this file, we did links, didn't we? Links to file log notes, so the permissions are irrelevant really, I think, in that case. These 9 characters usually contain R, W, X and hyphen, although you will see other characters like T and S, which I'll explain later. And they are divided into 3 groups: user, group and other. The first 3 are the user's permissions. So Train 1 owns these files, so he gets R and W on most of the files except that one where he's only got read permissions. The group permissions are the next 3. So anybody in the group users, which includes Train 2, Train A and Train X, get the second set of permissions. So they get read on all the files and execute on some of the files and the directories. And then O is anyone else. So anybody who logs in gets the last 3 are there, which means that it's very open Linux. Anybody can read any of my files or change into my directories. And we'll look at how you change that in a moment. Sorry, just stop there for a cough. The rest of the line are the number of links. A directory always has more than 1 link. So this directory's got 2 links, this one's got 4. The owner, which is Train 1, the group, which is users, size of the file, date and time, like last updated, and the file name. Now, the permissions determine access to the file. If you don't have read access, you can't read a file. If you don't have write access, you can't write to a file. On a file, if you don't have X access, you can't execute it. And on the directory, X access means that you can CD into it. And that's explained here. R is read, so on a file you can open and read. With W you can open and write. With X you can run as a program. So for instance here I can do /by because that's got executable permissions and run that as a program. If it's a hyphen you've got no access, so as it stands I can't write to the people file. That's there on purpose as an example. It's slightly different with directories. R means that you can list it using ls. W means that you can write to it, so you can add, delete and rename files. And X means that you can change into it with CD. In both cases, a hyphen means that you don't have any permissions. Now if we look at how permissions are evaluated, if I own a file, like pick a simple file, I can edit old file. I have write permissions to the file, so I can yank that line. Whoops, that went wrong. Beg your pardon. Don't know what happened there. I can yank that line with YY and copy it, save the file. An old file has now got multi-lines. That's because I have got write permissions on old file. So you get read, write, execute, whatever permissions you give yourself. Now the second set of permissions are for the group. If you're not the owner of a file, it asks are you in the group for the file. So let's CD into train 2 and look at train 2's files. Now train 2 owns these, same permissions as train 1 has got. We don't own them, we are train 1, but we are in the group users. So because we're in that group, we get the second set of permissions. So we get read to all of the files. So for instance here, I can try and edit old file. I can edit old file, but it comes up at the bottom here and says read only. Oh, it's just disappeared. I did say read only. Let's redraw the screen. Redraw the screen. Changing a read only file, it said, which is what it will do if I try and add lines there. And then right away it says this is read only, so I can't write to the file. My best bet is to quit, which I need to do with an exclamation mark. So because I'm in the group, I get read access to all of train 2's files. Let's go back to my own user. The third set, this is the first one is the user domain. Second one is the group domain we just looked at. The third one is the other domain and applies to anybody else who can log on, doesn't own the files, isn't in the group. Now an example of this is if we look at etc password. Root owns the file and has read and write access. It's in the root group which has read access, but it's also got read access for anyone else. So we can look at that file, I can tail it, see what users there are on the machine, because I have access there. Now if you don't want everybody looking at your files, you can change that access, and the way you do that is over the page using chmod. There are two ways of using chmod. One is to use letters, U for user, G for group, O for other, and A for all. So for instance, G will only change the 3 characters in the middle. You can use it to add, remove or set permissions. And the syntax with these letters, because you can always do it with numbers, you can also do it with numbers, which is over the page, is chmod, a combination of U, G, O or A, plus, minus or equals a combination of R, W, X, and then some file names. So for instance, nice at the moment there has RWX, RNX, RNX. I can chmod that and say for other and group, remove execute on nice. And then I can do an ls minus L on nice. And that's taken off the X permissions. If I want to set permissions on a set of files, like those beginning with a P, I could do chmod, what have we got? Set user equal to R and W on all the files that begin with a P, and do an ls minus L P asterisk, and that changed people to include a W because it didn't have a W there. If you want to remove permissions on a file like by, I can say chmod all equals minus minus minus. So it's now got no permissions, which means you can't read it, you can't write to it. And if you try and delete it, you'll get a warning message. Same for a directory. Chmod, the group on temp could be set to GWX. At the moment there's no W on temp for other or group. And of course you can do multiple files. So for instance, suppose I wanted to remove read, execute and write permissions on all my files but keep my own permissions. I could do chmod for other and group, remove RWX on everything, and do an ls minus L, and then other users can't see my files. They're protected. They're set to read and write. Now that's one way of doing it. The other way, the way I prefer, but it's up to you which way you do it, is to use octal numbers. And the way this works is normally you chmod and you provide 3 numbers, and the numbers are the 3 sets of permissions, user, group and other. And what you've got is R is 4, W is 2, X is 1 and 0 is hyphen, or hyphen is 0. Which means, if you think about it, RWX adds up to 7, 4, 2 and 1. R and W to 6, R minus X to 5, R is 4. So to put back the permissions that I had previously, what I could do is chmod everything to 644, which is read and write for me, read for everybody else, with an asterisk. Good if I could spell. What's the matter with me? It's early in the morning, relatively. There we go. So that's put everything back, but not everything, because I will have a problem. Because if you remember, you can't change directory into a directory unless you've got execute permissions on it. So permissions denied. So the other thing I need to change is I need to chmod 755 on my directories scr and temp. And then I'm sort of back where I was. I mean, admittedly, nice and by had execute permissions, so I could set by and nice back to where they were, and people only had read permissions, which is, if you look, read is 4, read is 444. So that, I think, is back where we started. Bit fiddly, but that's how you do it. Now, like I said, it's up to you. You can do it with letters, if you think that's easy, or with numbers, if you've done that before. You can actually do a conversion between the two. That's the next thing. We'll do a review exercise, but before we do, if we go across to here and search for a Chmod calculator. There are lots of these on the internet. And what you do here is you say, well, I want read and write for myself, read for the group, read for public. That's 644. Only read, that's 444. Give execute, like you would on the script, and it's 755. So the ones that are commonly used are 644 and 755. Now the exercise here looks at the group file. Copy it into your home directory, take the permissions off, and you'll probably find that you can't, or you will find, if you've no permissions on the file, you can't read a file, you can't write a file, and if you try and delete a file, you can't update a file. If you try and delete a file, you'll get a warning message. The second exercise here looks at doing a similar sort of thing with the directory temp. Set the permissions and check to see whether you can ls it, whether you can seed into it, whether you can remove files from it, and then put the permissions back again. So at this point in the video, I usually echo, no I don't, I usually figlet exercise. So you can see it if you're whizzing through, that's the idea. So I'll freeze this, you do the exercise, and then I'll come back with the solutions. Now these are the solutions. First one, copy the file across so you can chmod /ctc group to current directory with a dot. Change the group file and remove its permissions with a equals minus 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 and list it. Cat it, which is number 4, and you should find that you can't cat it. Try to append it using echo and redirection. You can't do that either. Try to remove it and you should get a warning message. And if you enter Y, you can remove the file. The second one, list the files in the directory temp. So ls temp, chmod a equals minus 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 temp, that removes all the permissions on the temp directory. List the directory to show that permissions are correct. You use ls minus ld to see the directory entry. Ls temp, you can't do that. Change into directory with cd, you can't do that. Try to remove a file in directory, you can't do that either. That's not right, is it? Beg your pardon. So I'll just correct that. I update these sometimes. I must have forgotten to update the solutions. Number 6 would be remove in temp. There's a file called A. That will fail. And then number 7, if I replace that with a 7, reset directory permissions to 755, and then you should have your directory back as it was. That's the end of the solutions, although I need to add some for sed. So what I'll do is I'll save that file. Where are we? There we go. And you'll find it, or a version of it, if you look in the SCR directory. It's called EX Solutions. There. It's not the latest one, but there are very few changes. I think only that last exercise there. And I will post a new version to the tar file, so the next time you install, or if anyone installs it, they'll get the new solutions. Right, what else do we do in here? Oh, the sticky bit. Right, this looks at special permissions. Close that. We'll go back up here. Okay, on most systems, the sticky bit is the T bit, and it's set on the directory /tmp. So if you do an ls -l on root, you'll find you've got two directories that come up in green. Backup, which has the T bit set, and temp. Backup I set up. Temp is normally there when you do the install. That's got the T bit set. Now when that is set on the directory, any user can create files in that directory, but those files are protected such that they can only be deleted by their owner or by root. So you don't need to change it, but that's how it is set by root. Chmod +T /backup. And if you have a look in temp, I mean, it's got all sorts of temporary files in it created by the system. But you can use it to store files, you can copy files there, but don't rely on them staying there for long, because they might well disappear if you reboot, for instance. The SUID bit, if we look at the password command, not the password file, the password command, well, this is the, let's look at them both. This is the password file. If you remember, we've only got read access as the other in the other group. But if you look at the password command, which on Linux is usually in USR bin, if it's not there, you can search for it. You'll see that it comes up in red, because it's dangerous stuff, and that there's an S bit there. That's the SUID bit. There is also a group ID bit, but I'm not going to explain that. You can look that up on the internet if you want. So if you see an S there, it's a group ID bit. This is the SUID bit. And what this does is, in order for a user to change their password, the system administrator sets the SUID bit, and then when you change the password, the user assumes the permissions of the owner of the file, which in this case is root. So when you run a command that's got the S bit set, you become root. So what hackers used to do in the past, if they got access to the root system, was set the S bit on something like Vim and log out. When they logged in again and used Vim, they became root. They had root permissions. And if you look in somewhere like the bin directory, there are several commands in there in red. There's mount, unmount, su, and fuser mount. There will be one set to red in other, well, not set to red, one showing in red because they've got the S bit set in other directories. You set the S bit in a similar way to the T bit with Chmod +S, but you, as an ordinary user, you don't set the T and S bit normally on files. Just explaining to you what they are. And then the last thing in this section is umask. Umask controls your default permissions. Now at the moment, if I create a file like that and then do an ls -l on A, my default permissions are R and W, R and R, and that's because my umask is set to 022. The first O is to do with things like the TNS bit, so ignore that one. Just look at the last three letters, characters, numbers. You can also do umask -S, and that will show you that user gets RWX. This is for directories, not files. RWX, group get RNX, and others get RNX. And the way this works is it takes your umask, the default is 022, and for a directory which is set to 777, it takes the umask away from the directory. So by default, if your umask is 022, your directory gets 755, which is normally what you want, which is read, write and execute for you and read and execute for everybody else. Same thing with files, and you start with 666, you take 022 away from 666 and you get 644, which is what you want on your files. Read and write, read and read. And that's explained there. Whoops, sorry. And there, let's colour that, why not? Now, if you want to change your default permissions, propose when you create new files you don't want other people to have permissions on them. What you do is you change your umask. So if I say umask 077 and then check my umask, what I'll get now will be RWX but nothing group or other. And that's because it takes 077 away from 777 and you get 700 for directories and 600 for files. So if I create a new file called AA and a new directory called AAA and then do an ls-l, my new file AA has just RW, my new directory has just RWX. It's not retrospective, so you have to change any files and directories that are already there yourself, but that makes your files more secure. However, be careful, because if you've got applications running which rely on certain permissions, they might well fail if you mess about changing the permissions. And that's the end of this section. I'll go back to the slides. So that's the end of this section. The notes next time, the sed batch editor and then Vim Advanced, and then we'll finish. I think there's something else to do. I will carry on doing ad hoc video tutorials. I might look at installing CentOS in VirtualBox, and then a Kali persistent USB stick, which means you can save files on the stick, and then install and configure Kali. Usual thing at the end, my plea which falls on deaf ears, for subscriptions, for likes and comments, recommendations and shares, feedback, questions and suggestions via email. But that's all for now. Thank you very much for listening, watching I suppose. Bye bye.